This video will show you how to get the limit as x approaches infinity. As we can see in this example, we want to get the limit as x approaches infinity of 3x to the 4 plus 5x squared minus 3x plus 4 all over 2x to the 4th plus x cubed plus x minus 6. Now, to get the value of this limit, you have to take note the very concept that the limit as x approaches infinity of 1 over x to any r, where r is a positive number, this is always equal to 0. At the same time, there is a rule in limits. Say this limit approaches any number, there is a constant, and there's x to the n is any number. You can always put the k outside the limit and then just retain x to the n. So for example, if you have limit as x approaches say 2 of 3x to the 5, this is equivalent to 3 limit as x approaches 2 of x to the 5. Therefore, the value by the substitution method, the limit is, you substitute 2 to the x, this is 2 to the 5, this is equal to 3 times 32, and this is equal to 6, and this is 9, so the limit is 96. So keep in mind, if there is a number before x to a number, say 2, 3, 4, and so on, you can always put that number outside of the limit and just take the limit of x to the n. Okay, so that's the same even if you have 1 over x to the r. For example, if you want to get the limit as x approaches, say, infinity of 5 over x squared, so this is equivalent to 5 limit as x approaches infinity of 1 over x squared. So look at how it's like factoring out the number. So this is 5 times 1. So if I put the 5 outside, then you have 1 over x squared. And from the rule that the limit as x approaches infinity of 1 over x to the r equal to 0, this would mean 5 times 0 equals 0. So the limit of this is also equal to 0. So these two important concepts will be used for us to find the limit of this rational expression. A very long numerator and a very long denominator. Okay, so let's apply the idea. Okay, so take note that there is a rule that when you get the limit of a quotient, meaning the limit of something being divided, you can actually get the limit, distribute the limit. So 3x to the 4 plus 5x squared minus 3x plus 4 all over the limit as x approaches infinity of 2x to the 4 plus x cubed plus x minus 6. You can actually do this. Okay? Now, but since this is infinity, you cannot just substitute infinity to every x. So there must be something that you needed to do with the expression. Okay, now also I want you to take note that this expression 3x to the 4 plus 5x squared minus 3x plus 4 all over 2x to the 4 plus x cubed plus x minus 6 will still be the same if I will multiply this by 1 over x to the 4 and 1 over x to the 4, because basically this is just 1. So multiplying the expression by 1 will not change the expression. So if I will get the limit of this expression, I can just get the limit of this. Okay, so I will be getting the limit of this instead. Now note, if I will simplify this, so this 1 over x to the 4 will be multiplied to every term in this polynomial. So our limit will become, so as x approaches infinity, so you have 3x to the 4 over x to the 4 plus 5x squared over x to the 4 minus 3x over x to the 4 plus 4 over x to the 4. And that will be the same with the denominator. So 2x to the 4 plus x over x to the 4 plus x cubed over x to the 4 plus x over x to the 4 minus 6 over x to the 4. Okay, now a while ago I started with separating the limits in the numerator and denominator, and it will not work directly because this is infinity. Again, substitution will not work directly on this. Okay, so we went to a step wherein we have to multiply the numerator and the denominator with 1 over x to the 4 and resulted into this expression. Okay, now from here I'll be going to this step. So I'll be applying this rule. Okay, so I want you to take note. So I'll be jumping into this space. Sorry, I have a limited space here. But so from here, this will become, let's simplify it first. Limit as x approaches infinity. So the numerator will become, so this is 3 plus this is 5 over x squared. This is minus 3 over x cubed. This is this is 4 over x to the 4. In the same way, this is 2x to the 4, x to the 4. This will be just 2. The next one will be 1 over x. This will become 1 over x cubed. And the last one will remain as 6 over x to the 4. Now, so I'll be taking the limit of the numerator and the limit of the denominator, as I explained a while ago in our initial step. Okay, so when I get the limit of the numerator and the denominator, so this will become limit as x approaches infinity of 3 plus 5 over x squared minus 3 over x cubed plus 4 over x to the 4. And all over limit as x approaches infinity of 2 plus 1 over x plus 1 over x cubed minus 6 over x to the 4. Now, after this, you'll be taking the limit of each term. Remember, one of the basic rules is that when you get the limit of a polynomial, or a sum or difference of terms and expressions, you can take the limit of each term. Now, the limit of a constant is the constant. So even if this is infinity, that is 1, that is negative 2, negative 3, 4, 1,000, 1,000,000, the limit of this number will remain as a number. So note, I am not, since I have a limited space, I will not be rewriting this into limit of 3, limit of 5 over x squared, limit of 3 over x cubed, limit of 4 over x to the 4. But I want you to follow how I'll be getting the limit of each. Now, so after you get the limit of 3, you have to get the limit of 5 over x squared. Now remember, I have an example a while ago that if you have the limit as x approaches infinity of 5 over x squared, you can put the 5 outside and then get the limit of 1 over x squared. And it will turn out to be that the limit of something, a number, actually a 1 over x to any exponent, will become a 0. So this became 5 times 0, so 5 times 0 is equal to 0. So if I get the limit of 5x squared, it will be 5 times 0, and this will just be a 0. In the same way, limit as x approaches infinity of 3 over x cubed will become 3 times the limit of 1 over x cubed, which is just also 3 times 0, or simply 0. 4 over x to the fourth will be 4 times the limit of 1 over x to the 4, which is just 0, so this is plus 0. So then all over, you apply the same thing. Limit of a constant number 2 will be the 2, and the rest here will become a 0. So plus 0 for 1 over x cubed, that's 1 over x to the r, the limit is 0, minus 6 times limit of x to the 4 is also equal to 0, so minus 0. Okay, so 3 plus 0 minus 0 plus 0 over 2 plus 0 plus 0 plus minus 0 will be 3 over 2, and the limit is 3 over 2. Actually, what we had from this explanation is actually the long way of getting the limit of a polynomial of a rational expression as x approaches infinity. As you notice, what we just did is actually we divided this expression by x to the 4, which is the highest exponent or the highest power of the expression. So x to the 4 definitely is the highest, so we divided it by x to the 4. And that will be the same thing even if you have x to the 5, x to the 6. You just have to check which one has the highest degree. Then you divide each term by that highest power. And then applying the rule, limit as x approaches infinity of 1 over x to a number will always result to a 0. So hence, if you observe from this limit, whenever you have a number over an x to a power, the limit becomes 0, provided that this is infinity. Limit as x approaches infinity of a number over x cubed is also a 0. Limit as x approaches infinity of a number over x to the 4 is also 0. But of course, limit of a number of a constant will be the constant. So that is 3 over 2. Okay, so the question now is, how can we simplify the solution to this very long explanation? Okay, so I want you to go back to the problem. This is x to the 4, and this is also x to the 4. This has the same idea with the horizontal asymptotes. Actually, this is the procedure on how to get the horizontal asymptotes. As x approaches infinity, you are actually doing or finding the horizontal asymptotes. So if you remember how we got the horizontal asymptotes, this is the same exact thing. Okay? When the degrees are the same, then all you have to do is to get the coefficient of the numerator, the leading coefficient of the numerator, divided by the leading coefficient of the denominator. So without going through this very long computation, the limit of this as x approaches infinity is simply 3 over 2. Okay? Now, just to extend the idea, because you might be encountering problems wherein the degree of the numerator is higher than the degree of the denominator, then there will be no limit. The limit is undefined. Okay? And then if the limit is higher in the denominator, I mean the degree is higher in the denominator, so say this is 4 and this is 5, then the limit is equal to 0. Okay? So, but again, we focus our attention on how to get this limit. Is the case wherein the degree of the numerator is the same with the degree of the denominator. So get the leading coefficient of each part of the fraction. So this is 3 and this is 2. So the limit as x approaches infinity is simply 3 over 2. Okay, so you might be asking, so how are we going to do this in the test? If you know the rule, then you just apply the rule. No need to have this lengthy computation. Okay, but this computation, this solution, is providing you the reason why we can just simply get the 3 over 2. So if somebody will ask you, how did you know that this is 3 over 2? So you can explain to the person that this is how you do it. Okay, but since you know how to do it directly, then just get it directly. Okay, that's the fastest way. Only if someone will ask you to explain, then you do the long computation. Okay, so I hope with that very long solution and with the summary, you were able to understand what I'm trying to point out here, how to get the limit as x approaches infinity. That's it.